In a world that thrives on technological progress, there are moments when the promise of invincibility can become a fatal illusion. This story begins with an audacious claim. This pipe is indestructible. Engineers touted it as the pinnacle of modern design, a marvel of material science that would stand the test of time. It was the backbone of an important infrastructure project, crucial for transporting highly pressurized liquids through a complex system of pipes. But how could something so seemingly flawless fail so catastrophically? Imagine a pipe, declared by experts to be practically invincible, placed in one of the most critical systems of its time. It was designed to withstand immense pressure, extreme weather, and any external force that could threaten its integrity. It was supposed to be the perfect solution. Yet, the pipe's story is one of irony, as it was this very overconfidence in its invulnerability that set the stage for an unimaginable disaster. The engineers who built it were confident that it would be the epitome of safety and reliability. The materials used were cutting-edge, and the design was a culmination of years of research and development. No one anticipated that what seemed like the perfect structure could harbor the seeds of its own destruction. It wasn't just any pipe. It was supposed to be a symbol of progress, a testament to human ingenuity. So, when cracks began to form, they were initially dismissed as nothing more than minor imperfections. After all, how could something so invincible ever fail? But the cracks didn't stay small for long. Before we dive deeper into how something as seemingly perfect as this pipe could lead to the loss of 582 lives, think about this. What happens when we place blind faith in something because we believe it's invulnerable? What are the consequences when we overlook the smallest signs that something might be wrong? Stick around, because the answers might surprise you. And this tragic event is a stark reminder that no system, no matter how perfect it seems, is truly invincible. If you're enjoying this video so far, don't forget to leave a comment sharing your thoughts on what you think caused this industrial disaster. Also, if you want to keep learning about these tragic events, hit the like button and subscribe to the channel for more. Now, let's dive deeper into the next part of this story. The story of this pipe begins long before its tragic failure. Engineers and scientists worked tirelessly to create what they believed would be the most advanced and durable pipe ever built. It wasn't just a pipe. It was supposed to be a revolution in industrial design. The materials were chosen carefully for their strength and resistance, with cutting-edge alloys and reinforced structures meant to withstand the harshest conditions. In the early stages, the project was heralded as a triumph of engineering. The pipe was designed to endure extreme pressure, to hold fast against both internal and external forces, and to last for decades without fail. It was seen as a marvel of modern technology, crafted with precision, calculation, and careful testing. The engineers believed that their work would stand the test of time, a beacon of industrial innovation. The pipe's design was based on years of research into materials science, stress analysis, and the ability to withstand corrosion and other damaging factors. Extensive testing showed that the pipe could handle far more pressure than its intended use required. Engineers confidently declared it indestructible, and for a time, this belief seemed justified. No other material had ever been used in such a way, and there was little reason to question its capabilities. But it was precisely this overwhelming confidence that led to an underestimation of one of the most crucial elements of engineering vigilance. When something is built to be indestructible, we often stop asking the critical questions. We forget to look for the flaws, no matter how small. And that is where the problem began. While the pipe was constructed with the best technology available, there was an unspoken assumption that it was impervious to the minor errors and flaws that often plague other industrial designs. What no one anticipated was that these small, seemingly insignificant imperfections might add up over time, eventually leading to catastrophic failure. This pipe, the indestructible one, was meant to be the symbol of safety and innovation. It was to protect the workers, the machinery, and the lives that depended on it. But as we'll soon see, even the strongest structures can be brought down by something as small as a crack that no one thought would ever appear in a system that was perfect. The stakes surrounding the use of this pipe were incredibly high. It wasn't just a simple piece of infrastructure. It was the lifeblood of an entire operation. This pipe wasn't transporting water or gas. It was integral to a much larger system, one that involved hazardous chemicals, massive industrial operations, and, in some cases, lives on the line. Engineers and workers alike trusted the pipe because they were told it was indestructible. It was used in critical systems factories, power plants, and even in offshore platforms where failure was simply not an option. Imagine a refinery that relied on the smooth flow of chemicals through hundreds of miles of piping, or an energy plant where this pipe helped to power entire cities. This was not just a small cog in the machine. It was the core around which everything else depended. The pipe's placement in these environments heightened the danger exponentially. These weren't just civilian industries. Many of them were high risk, dealing with volatile substances. A malfunction here didn't mean a minor inconvenience, it meant massive disruptions, environmental hazards, and in the worst-case scenarios, lives lost. Workers who installed the pipe, and those who relied on it daily, operated under the assumption that they were working with the safest, most reliable material available. They worked in confidence, believing that the promises made by the engineers were backed up by results. But, as often happens in high-stakes environments, overconfidence started to overshadow caution. The pipe's use wasn't just about efficiency, it was about safety. When a company's most important systems rely on the strength of a single piece of equipment, the consequences of a failure are unimaginable. It wasn't just the engineers who had staked everything on this pipe. It was the entire industry, the workers, and the communities dependent on the energy and chemicals flowing through this pipeline. This wasn't just a pipe, it was a ticking time bomb. But no one knew it yet. It began subtly. A small crack here, a slight flaw there. At first, these imperfections were overlooked or simply dismissed as minor issues that came with the territory of any large industrial system. But what was thought to be inconsequential would soon become the first warning signs of something far more catastrophic. The cracks were there, growing silently, but no one paid them the attention they deserved. In industrial systems, it's common for equipment to show signs of wear and tear over time, especially under high pressure. However, the belief that this pipe was indestructible led many to assume that it could never be the source of any significant problems. The engineers who designed it had conducted thorough testing, and its structural integrity was considered flawless. Any crack, no matter how small, was seen as an anomaly, an outlier that would be easily fixed. But this wasn't just any crack. Small cracks are often ignored, written off as part of the normal wear on a system. However, what most people didn't realize was that these seemingly insignificant flaws could be the beginning of something much larger. Each crack, each minute imperfection, was weakening the pipe structure bit by bit, and no one had the foresight to connect the dots. The problem with ignoring these early signs is that, over time, they compound. The cracks grew, but they grew at a pace that was difficult to detect without more rigorous inspection. As long as the pipe continued to function, pushing chemicals, carrying gas, supporting vital operations, everyone was willing to overlook the warning signs. The initial damage seemed to be under control, but the situation was deteriorating slowly and invisibly. The pipe was still in use, still working perfectly as far as anyone could tell, and because it was indestructible, no one thought to question its safety. But deep inside, beneath the surface, the damage was mounting. No one realized that the very structure that had been praised for its invulnerability was slowly succumbing to the forces it was meant to resist. It was a dangerous game of ignoring the small signs that, in the end, would prove to be the catalyst for the disaster that followed. The unthinkable happened on a day that started just like any other. For the engineers, the workers, and the communities that depended on the pipe, there were no signs that anything would go wrong. But beneath the surface, the cracks that had been ignored for so long were silently growing. The disaster was waiting to unfold. No one could predict when, but it was coming. On that fateful day, the pressure inside the pipe reached a critical point, far higher than it had ever been before. This was no random incident. It was a tragic chain reaction that started with something small, something that no one had taken seriously. The crack that had been forming over time, unnoticed and unchecked, finally gave way. The pipe, once deemed indestructible, ruptured under the strain. The explosion was devastating. In an instant, the system that had been built to last for decades collapsed. A flash of fire, an earth-shaking boom, and a massive plume of smoke engulfed everything in its path. The force of the explosion was so intense that it left destruction in its wake, leveling buildings, setting fire to nearby structures, and causing chaos in every direction. For those who were nearby, it was a nightmare. The blast sent debris flying, and the aftermath was filled with thick smoke and burning ruins. People were trapped in the wreckage, some with life-threatening injuries, others caught in the devastating firestorm. Emergency responders rushed to the scene, but the scale of the disaster was overwhelming. It wasn't just an industrial accident, it was a tragedy that affected countless families and workers, people who had trusted that this indestructible pipe would keep them safe. In the blink of an eye, the pipe that had been designed to ensure safety had become the cause of unspeakable destruction. The explosion was more than just a physical rupture, it was a symbol of how a small, overlooked flaw could lead to catastrophic consequences. The shock waves from the explosion rippled far beyond the immediate vicinity. Entire families lost loved ones, and entire communities were forever altered. It wasn't just the material loss that would be felt for years to come, it was the emotional toll, the grief that would never truly heal. The explosion was not just an industrial disaster, it was a human tragedy. The lives lost that day can never be quantified by numbers alone. Behind each statistic was a person, a family member, a friend, a worker, with dreams and aspirations. As the dust settled, the full scale of the devastation became painfully clear. 582 people had lost their lives in an instant. The shockwaves of this tragedy rippled through the community. Families were torn apart, and lives that had once been full of promise were abruptly extinguished. Mothers, fathers, sons, and daughters who had kissed their loved ones goodbye that morning were now forever gone. For the survivors, it was a nightmarish scenario, a waking hell where they had to grapple with the haunting realization that they would never see their loved ones again. The workers who had been close to the blast site were among the first to perish, their bodies caught in the debris and fire. Many of them had spent years working with the pipe, trusting in its supposed invulnerability. They had worked side by side, day in and day out, believing in the safety of the system. Now, their trust had been shattered in the worst way imaginable. For the families left behind, the pain was beyond measure. Some families had lost multiple members, as fathers and sons, or husbands and wives, all worked at the same facility. The community was left to pick up the pieces, but no amount of reconstruction could ever bring back what was lost. The lives lost in the explosion were not just numbers, they were vibrant, living people with stories, personalities, and futures. The emotional toll on the survivors was equally devastating. Many had witnessed the carnage firsthand, and some had even managed to escape the inferno, only to be left with physical and emotional scars that would last a lifetime. The trauma of that day left its mark on the community, spreading grief and despair far beyond the immediate blast zone. The aftermath of the explosion was not just about rebuilding what had been destroyed. It was about trying to heal the emotional and psychological wounds that would linger for years to come. The families of the victims and the survivors alike would have to live with the echoes of that day, with the question of how something so indestructible could lead to such a monumental loss. In the wake of the disaster, the question on everyone's mind was, who was responsible? How could such a catastrophic failure occur when the pipe was designed to be indestructible? The answer, as it turned out, was not as simple as pointing fingers at a single person or entity. The explosion had its roots in a series of engineering miscalculations, legal oversights, and corporate negligence, all of which allowed a small, overlooked flaw to grow into a tragedy of unimaginable proportions. At the heart of the blame was the overconfidence in the pipe's design. Engineers, secure in their belief that they had created the ultimate system, had ignored the subtle warning signs and failed to question the very assumption that the pipe could not fail. The small cracks, which were initially dismissed as irrelevant, had been the first signs of something much larger, and yet they went unchecked. Had proper inspections been conducted with more attention to detail, perhaps the crack could have been detected earlier and prevented. But the focus had been on the pipe's supposed indestructibility rather than its actual vulnerability. Then there was the issue of maintenance. While the pipe was still considered perfect, the routine checks and tests that should have identified potential weaknesses were either rushed or not thorough enough. The assumption that the pipe would last forever led to a culture of complacency, and when signs of trouble did appear, they were minimized or ignored. Workers and engineers, perhaps driven by tight deadlines or financial pressures, failed to take the necessary precautions. But the failure wasn't just a technical one. Legal responsibility also loomed large. The corporation behind the pipe's construction, once hailed as a pioneer in industrial safety, found itself at the center of a storm of lawsuits and public outrage. The company's executives, once proud of their product, now faced the consequences of having cut corners in their pursuit of profit. While the engineers might have been the ones who designed the pipe, the corporate leadership was ultimately responsible for ensuring its safety. Despite this, the legal battles that followed were long and drawn out. The victims' families sought justice, but the road to accountability was murky. Corporations have deep pockets and high-powered lawyers, and often it felt like the victims' voices were drowned out by the noise of legalese and corporate defenses. It wasn't just a fight for compensation, it was a fight for recognition, for the acknowledgement that lives were lost due to preventable mistakes. In the end, who was to blame? Was it the engineers who had failed to question their own assumptions? Was it the maintenance crew who failed to spot the cracks in time? Or was it the corporate leadership that, in their rush to innovate and profit, ignored the very real risks their creation posed? The truth was more complex than any one party could bear. The disaster highlighted a fundamental flaw in both the engineering and corporate worlds: overconfidence. The belief that something is invulnerable can often blind those responsible to the dangers lurking in the details. And once the disaster struck, the response was slow, reactive, and often legally defensive. For the victims, their pursuit of justice would be an uphill battle that would take years, with many questions left unanswered. The catastrophic explosion that claimed 582 lives was not just a disaster, it was a wake-up call for the entire engineering community. The aftermath revealed glaring flaws in the way engineers, corporations, and governments approached safety, risk, and design. In the years that followed, the lessons learned from this tragedy became the foundation for sweeping changes in industrial engineering practices, leading to stricter safety regulations and a deeper understanding of risk management. One of the most important lessons learned was the recognition that no system, no matter how advanced, could be considered indestructible. The explosion served as a stark reminder that even the most meticulously designed technologies could fail, sometimes in ways that were unforeseen. The engineers who had worked on the pipe had assumed it was perfect, but the small crack that began it all exposed a critical flaw in their thinking: overconfidence in the face of complexity. In the wake of the disaster, the engineering community was forced to re-evaluate its approach to safety. This included a renewed focus on the importance of rigorous testing and the necessity of pushing beyond theoretical limits. The engineers who had worked on the pipe had done their calculations, but they had failed to account for the real-world complexities of the materials they were using. It was a failure to recognize the true risks that led to the breakdown. In response, new standards for material testing and failure analysis were developed. The focus shifted from ensuring that systems could withstand expected conditions to preparing for the unexpected. Engineers began to implement more comprehensive stress tests, ensuring that systems would be able to handle extreme conditions without catastrophic failure. The goal was to anticipate potential failure points long before they could lead to disaster, taking into account factors like age, environmental conditions, and wear and tear over time. The pipe disaster also emphasized the importance of safety in the design process. Previously, engineers often prioritized efficiency, cost-effectiveness, and performance over long-term safety considerations. The aftermath of the explosion forced the engineering community to shift its focus, putting safety at the forefront of design. It became clear that even small oversight or neglect could lead to disastrous results, especially when it came to systems that were critical to public safety. Beyond the immediate lessons learned, the disaster sparked a broader conversation about the ethical responsibilities of engineers and corporations. The failure of the indestructible pipe highlighted how greed, overconfidence, and negligence could influence engineering decisions. Moving forward, the industry began to emphasize the importance of accountability at all levels, from the design phase to ongoing maintenance and monitoring. As the years went on, the disaster's lessons were integrated into new safety protocols and regulations. Many industries, particularly those involving hazardous materials and higher-risk operations, adopted stricter safety measures and reformed their inspection practices. The tragedy became a symbol for the need for constant vigilance, caution, and humility in the face of technological progress. While engineers had learned from the disaster, it was clear that such lessons should never be forgotten. The explosion that killed 582 people left a scar not just on the landscape, but on the collective memory of the community, the industry, and the engineering world. Over time, the story of the disaster became a somber lesson in safety, risk, and the human cost of negligence. But as with all tragedies, it is the legacy, the enduring lessons that matter most. For the families and friends who lost loved ones, the pain never truly faded. In the aftermath, communities rallied together, but the emotional scars were deep. For many, the grief remained a constant reminder of how quickly normalcy could be shattered. The tragedy wasn't just a moment of destruction, it was a permanent shift in their lives. The victims' names became symbols of the need for better safety measures, but for those who loved them, they would never be just statistics. They were fathers, mothers, brothers, sisters, people with families, hopes, and dreams who never had the chance to fulfill them. The community, however, found ways to honor their memory. Memorials were built, and every year, on the anniversary of the explosion, people gathered to remember the lives lost. In schools and workplaces, discussions were held about safety, risk management, and the importance of vigilance. The tragedy, though painful, spurred the community into action, ensuring that the lives lost would not be in vain. In the world of engineering, the explosion became a turning point. The pipe that was once heralded as a technological marvel was now viewed with a much more critical eye. The industry had learned from its mistakes, but it was the legacy of the 582 that provided the most powerful motivation for change. New regulations were implemented, stricter safety protocols enforced, and the focus shifted from just building to ensuring the long-term safety of any engineering project. The tragedy had revealed that true success wasn't just about creating something that worked, it was about creating something that could endure, no matter the unforeseen challenges. For many years after, the story of the pipe disaster was told in engineering schools, corporate boardrooms, and public safety discussions. It served as a constant reminder that overconfidence, neglect, and a failure to recognize risk could have far-reaching consequences. The legacy was not just about the lessons learned, but the ongoing work to make sure that similar mistakes would never happen again. And yet, in the midst of all the technical changes, one thing remained: the lives of the 582 people who had perished in the explosion. Their memories became intertwined with the very fabric of the engineering field, forever shaping how future generations would approach safety, oversight, and accountability. The question no longer was how to prevent failure, but how to honor those lost and ensure their legacy continued through the work that engineers and communities would do going forward. As we reflect on the tragedy, it's clear that the human cost cannot be measured by engineering blueprints or safety regulations alone. The lives lost in the explosion were not just statistics, they were people with families, dreams, and futures. In the cold calculations of safety protocols, it's easy to forget that every number represents a person. The explosion in the industrial complex will forever be a painful chapter in the history of engineering. But for the survivors, the families, and the entire community, it was more than a disaster. It was a devastating, irreversible loss. And while we have learned from the mistakes that led to the disaster, it is essential to remember that the ultimate lesson is the importance of the human element in all engineering work. The tragedy underscored the fact that technology, no matter how advanced, can never be fully reliable without the constant vigilance, oversight, and compassion of those who design, maintain, and operate it. It's not just about making things work, it's about ensuring they don't fail when lives are on the line. As you watch this video, think about the impact of this tragedy. Think about the 582 people who never made it home, whose lives were cut short in an instant. Ask yourself, what can we do to ensure that future generations of engineers, workers, and decision-makers don't repeat the same mistakes? How can we make sure that no other community has to bear the weight of such a loss? The lessons learned from this disaster, while painful, have helped shape the modern engineering landscape. They have driven new standards of safety, risk management, and accountability. But the real challenge lies in never forgetting the human cost behind these lessons. If you've made it this far into the video, we ask that you leave a comment below. Share your thoughts on how we can continue to learn from such tragedies and what steps should be taken to avoid future disasters. Don't forget to hit the like button and subscribe to our channel if you haven't already, as we continue to explore stories that shape the world we live in. Thank you for watching, and thank you for honoring the memory of the 582 lives lost. Remember, their legacy lives on in the changes we continue to make.